Hello, my name is Mallory Robinson, and the concept that I'm going to be explaining today for calculus is the intermediate value theorem. The intermediate value theorem means that it states that f of x is continuous on the interval a through b, provided that f of a does not equal f of b. Then if d is any number between f of a and f of b, then there is at least one c between a and b, such that f of c is equal to d. More simply put, provided f is continuous on a to b, and f of a does not equal f of b, then every number between the output at a and the output at b is also an output for f. An example could be, suppose that for the function f of x, it's known that f of 0 equals 3, and f of 2 is equal to 6. We cannot use the IVT, or intermediate value theorem, to support the claim that f of c is equal to 5 for some c between 0 and 2, even though 5 is in between 3 and 6. The IVT does not apply because we don't know if f of x is continuous. You can only apply the IVT if it is known that the f of x is continuous. Another good example could be, suppose that f of x is continuous and differentiable, so we're provided this information on the interval -4 is less than or equal to x, which is less than or equal to 3. The selected values are below. Determine if f of x has any zeros. Got the table right here. This is what's provided. And we are seeing if, in each of the following, decide that the intermediate value, if it can or cannot be used to justify the stated conclusion, and explain why or why not. The following table gives some function values for the continuous function g of x. Therefore, there exists some r in interval 0 and 0, 2, for which f of r is equal to 5. And since we are provided that it is continuous and we show that r is in the interval between the numbers provided, then the IVT can in fact apply. And why is yes, because g of x is continuous and 5 is in the number between 7 and 3. Thank you very much for listening to my explanation on the IVT, and I hope you found this helpful.